What up, Algebra 2 dudes? Let's get started with this. I think that one of my homeworks is wrong, so I'm helping you guys out with some homework that was due today, the 8th of February. And so we'll take a look at these things and graphing them. I'm not going to screen share with you because I'll probably be doing most of my writing up on the board, but let me take a look at something right here. Let's see. The homework that was due today is Rat 5, page 414. Let's preview it. And we'll go to question number 11. We'll start off with that one, and then we'll do a different one after that. So number 11. Okay, all right, here's what it looks like to me. Start off with a vertical asymptote. In fact, I'll tell you what, let me just do this. Okay. All right, number 11. It kind of has your graph right here, and you got a vertical asymptote at 1, and there's almost like a bounce off at 2, and then this thing is at -2 over here, and it also has a y-intercept of -8. -8. All right, cool. Are we cool with that? Here, there. All right, good. This is 1 right here. This is 2 right here. This is -2 right here. I need one-on-one help. Okay, all right, Bradley, I can do one-on-one help with you. Totally, that's fine. I'm going to do some class help with you on choose a problem between 5 and 10. And I'll help you out with one of those as well. All right, so when I'm looking at this, there is no horizontal asymptote, right? There's no line that this thing tends towards as it goes off to infinity. And it's not 0 either. No, Sophia, it's not 0, because if it were 0, it would go something like this. You see? So it's not 0. The horizontal asymptote is not 0. And we've seen where it's a slanted asymptote, right? Where the asymptote is like a slanted line, like that. And that happens when the degree of the numerator is bigger than the degree of the denominator. For example, like x cubed over x squared, right? Because x cubed over x squared is just x, and graph of x would look like a slanted line, and that's where you would get like a slanted asymptote. But this asymptote is not slanted, it's not horizontal. We can figure this out, and you don't need to do this kind of analysis, but I'm just showing you kind of what I'm looking at. Yeah, exactly. I think it's kind of a parabola kind of deal, right? It almost looks like if I were to zoom out, or if I were to like cover up this middle part right here, you would say, hey, that kind of looks like a parabola as far as the end behavior goes, right? Erasing that middle part. So I'm suspecting that the degree of the numerator is going to be 2 times bigger than the degree of the denominator. And that's some advanced insight. But I'm just letting you know. I mean, does that kind of make sense to you? You don't need to know that kind of analysis for me to basically talk about it. I'm just saying, I'm thinking that that's how the answer is going to be. I usually always start off with, all right, let's go with the denominator. That's totally going to be x minus 1. Right? I only see one vertical asymptote, x minus 1. Now up on top, I'm thinking that I'm going to go with an x plus 2, x minus 2. Because I'm looking at my 2 intercepts. We cool? All right, Lucas already caught me on something, and actually Sophia's caught me on something as well. You're absolutely right. This thing right here is going to be a square right there. Emma and Bradley, do you understand why there's a square on that sucker? Not because it's parabola, no. Yeah, exactly, because at that particular x minus 2, that references this point, it hits and it bounces. It touches and bounces back. Another thing, in fact, I was going to leave the square off of there, right? And then I was going to say, well, look at the degree of the numerator, which is just x squared, and the degree of the denominator, it's x. That's not what we expected to see. Remember, I told you the degree of the numerator will be 2 degrees bigger than the denominator. And if I have x squared, that's just going to be, 1 degree bigger than the denominator. You guys understand what I mean by degrees? All right. But now that I have this square here, that makes the top equivalent to pretty much x cubed, and the bottom pretty much equivalent to just x. Which, if I reduce that, that's just straight up x squared. I should put a squiggly equal sign here because I'm, doing my approximation kind of thing. And then that is my horizontal asymptote, which is good because I'm thinking that's, like we said, we thought that our horizontal asymptote, it's not horizontal at all. It's parabolic in nature. That horizontal asymptote is going to be x squared, which is a good thing. Now, again, you didn't have to go through all of that analysis off the bat. The only thing you really needed to know was, hey, there's a vertical asymptote here that governs my denominator, and there's my 2 intercepts, which is the x plus 2 and x minus 2. But this one right here is going to be squared. That's all you need to know. I'm trying to read what you guys are saying to each other. Paper is generally better for you to memorize stuff. Huh. What are you guys typing to each other? Oh, okay. All right. All right, but I think that's your answer, right? Oh, here's a good way to double check your answer. Let's calculate out the y-intercept. And in calculating out the y-intercept, I simply just take all the x's over here and I plug in y equals 0. So I've got 2 times negative 2 squared divided by negative 1. So 2 times negative 2 squared, that would be 2 times 4, which is 8, divided by negative 1 gives me negative 8. Oh, good. So here's what you would probably want to put in Desmos, or not in Desmos, but in the computer. And Sophia, you're absolutely right. I could have gotten it totally wrong. I could have accidentally put in the wrong numbers, and we'll check that right now. But what I would put in the thing is, well, I need to FOIL this whole dang thing out, right? That's the game we play for that. Give me a second. I've got a phone call. You mind if I take this and then I'll just tell him I'm going to call him back? Hello? Hey.
I was doing some math today.
Some math with Ben?
No, just on my own.
Okay.
To see about maybe going back to work.
Yeah.
You're really poor.
Yeah.
And I was doing some math about how much I have to earn just to be able to pay for Ben, Griffin, Shiloh to go to child care. You know what I mean?
Ben, Griffin, and Charlotte?
Yeah, even though Ben is older, he has to go to A+.
Oh, yeah.
Nobody works his work 2:30. You know what I mean? So all the kids go to A+.
Yeah.
So that's $200 for Ben in Shiloh. Griffin, looking at the average cost for him, he's 3 years old at Potty Tree.
Yeah.
It would cost $860.
Oh my gosh.
And so basically,
You-
I would have to make over 12.50 an hour just to be able to pay for childcare.
To break even.
Yeah.
And that doesn't include transportation.
That doesn't even cost, like, that's not even like how much it costs.
Or extra food for eating out and that kind of stuff. Can I call you back about this? Because I'm actually in class right now. I should have started off with that. But I'll call you back. All right. Okay. Love you. Bye. Sorry about that. So I foiled this thing out right here. And then this is just the numerator because I didn't have enough space. And then here's my denominator. So my answer would probably be 1, -2, -4, 8. That's for the A, B, C, and D. And then E is 0, 0, 1, and -1. Those are my numbers. Let me just double check to see if I got that correct. If I plugged in those numbers correctly. All right. Bradley, did you end up choosing your problem that you wanted me to cover? Okay, let's see. Oh, 1. Huh. I plugged in totally different numbers. I don't know why I chose those ones. All right, 1. So you're right. You're right for getting it wrong because it was wrong. -2, -4, and 8, 0, 0, 1, -1. Okay. All right. Okay, save that. All right. So, Sophia, you're right. If you got that answer, then you totally got the right answer. And I screwed up the plugging it into the computer and everything. I apologize. Bradley, did you choose one yet? Or can I go on to the topic I need to cover today, which is actually a lot. So I actually probably need to cover that. But I promised I would give you 2, so I'm giving you 2. Unless you don't choose one. All right, does anyone else want to choose one for me to cover? Oh, number 6. All right, cool. I can do number 6. Sorry, Genesis. I promised Bradley I would let him choose for this one. All right, let's do number 6. I'm going to do this one with no insight, just straight up as best as I can do it. Wow, that thing looks confusing. All right, pull up number 6 for you guys. It's on a new tab so you guys can take a look at it. I'm not going to draw that out. But I will write down some information. I see a vertical asymptote at x at -2, 1, 3, and I see x-intercepts at -3, 2, 4. And my y-intercept is at 8. We're cool with that? Oh, and I also see a horizontal asymptote at 2. Are we cool with that? And then Emma's saying thank you. Why are you saying thank you, Emma? Oh, because I'm doing today's homework for you. Oh, you're welcome. All right. boom, right off the vertical asymptotes. Immediately, just grab those those denominator ones. So it's x plus 2, x minus 1, x minus 3. Boom, boom, and boom. We cool with that? The only complication here is, remember to get the opposite signs inside those parentheses. The y-intercepts, that would be x plus 3, x minus 2, x minus 4. We cool with that? All right, and let's see. The y-intercept, one of the things I could do is plug in x equals 0 and check to see if my y-intercept is positive or negative and if it's anywhere close to 8. I'm thinking it's not going to be close to 8. I'll tell you why. But let's just do that right off the bat. So we took care of the vertical asymptotes, we took care of the x-intercepts, and now we're looking at the y-intercept. So we plug in 0 here. So I really have 3 times negative 2 times negative 4 divided by positive 2 times negative 1 times negative 3. So that would give me this negative cancels out with that negative, negative, and negative here. 3 cancels out with that 3. This cancels out with that. So I really have 4 divided by 1, which is 4. It's not got the right y-intercept. Do you notice that? There we go. So in order to give it the right y-intercept, maybe I should say put a 2 out in front there. We cool with that? So that means my original thing would have a 2 out in front there. Because putting a 2 out in front here, or 1/2, or a 3/4, or a 400 out in front there, that doesn't change your vertical asymptotes or your x-intercepts. That will keep those the same. It will just vertically stretch or compress your graph. Does that make sense? And I actually knew that there was going to be a 2 out there because of this right here. Because if that 2 wasn't there, then the horizontal asymptote would be x cubed, right? This is approximately equal to x cubed over x cubed. The degree on top is x cubed. The degree on bottom is x cubed, which is equal to 1. That gives me a horizontal asymptote at 1. Do you see what I mean? But what I really want is for the horizontal asymptote to be at 2. So if I put a 2 out here, that's going to make it 2x cubed over x cubed, which is a horizontal asymptote of 2. Does that make sense? So yeah. Sophia says, I look at the horizontal asymptote before I go for the y-intercept. And I really don't care which one you look at. I mean, as long as you guys can get all of this information, I assume that you guys can get the graphs correct. And vice versa. As long as you guys can get the graphs, as long as I give you the graphs, I want you guys to be able to get all this information. We cool with that? All right. Now for the big pain in the butt part is multiplying all of this out. Got it? Sophia, what do you mean you have a hard time determining the orientation? Are you talking about flipping it upside down or it being right side up? Is that what you're saying? All right. What Sophia is saying is she has a hard time if the graph is, like this when it's supposed to be like this. And I would say, Sophia, the best thing that you guys can do is the y-intercept. Because if your graph is supposed to be like this and you plug in the numbers and you end up getting a positive y-intercept, then hey, I'm just going to slap on a big negative out in front there. All right. Multiplying all of this junk out and that kind of stuff, that's a pain in the butt. And I don't know if I told you this before. I don't mind you guys plugging this into Wolfram Alpha, and then Wolfram Alpha should be able to simplify it for you. Wait a second, I could have done that this whole time? That's cheating. Yeah, I don't mind. Now, Sophia's like, what? I had to multiply this sucker out by hand every single time. Are you kidding me? I could have just plugged this thing into Wolfram Alpha and have Wolfram Alpha simplify it for me? Yeah, you could have. But, Sophia, you are way better at multiplying out and foiling things. And that's going to serve you really well in the coming weeks. And it's also going to serve you really well when you get to calculus. You're going to need to be able to foil stuff in your head like nobody's business. And the fact of the matter is, you're better at it than probably your classmates are. And that's a good thing. All right? So don't be all upset that I'm, letting you guys know. Plus, I let everyone know pretty late in the game. All right, what's up, Bradley? I did 2 of them. And Emma, thanks for chatting up a lot more. It's good to have you participating in our conversations. Do I have any time? I don't really have it. I think you should do it. Yeah, what? I think you should do what? Which one? Bradley, I'm responding to you. What is it that you need? Oh. Okay. Oh, you want me to multiply it all out? I do ones where you have to multiply it. Do you not know how to multiply it all out? Don't feel bad if you say no. I don't know how to multiply it all out. I'd like for you to show me. I don't mind. Just let me know. So. Oh, okay. You're not good when there's 3 parentheses. All right. So here's what I do. You can do 2 parentheses, right, Bradley? That's the FOIL thing. All right. All right, cool. Let's start there. Let's go with x plus 3 times x minus 1 times x minus 2. I'm just making it up. It's a different problem, I guess. You can do the 2 in your sleep. So let's just do 2 of them. Okay? This would be x squared minus 3x plus 2. Are we cool with that? All right. Doing 3 of them, doing this one to this one is not hard. It really just takes a lot of writing, but it's not hard at all. What I think about is I just think, okay, this x has to meet everyone inside of this parentheses. So all I do is I write down this second parentheses, but I multiply everything by x. So if it's an x squared, it's going to become an x cubed. Negative 3x squared, 2x. So let me just write it down. X cubed minus 3x squared plus 2x. Are we cool? All right. You know what? Let me change this to a negative sign real quick. That just makes the problem harder, which is a good thing. Okay. Then what I do is after I multiply everything through by x to here, I go through and I multiply everything by negative 3. So that becomes negative 3x squared, positive 9x, negative 6. Did I confuse anybody? Negative 3x squared plus 9x minus 6. I know, it looks horrible. It's not hard. You just write the whole sucker out. It really isn't hard. It's just a matter of writing stuff down. All right. And then I can combine like terms. So This will be x cubed minus 6x squared. That takes care of this one, and this one. Plus 11x minus 6. That's my answer. Check, check, and check. I think that when you try to maybe do it in the clever way, it's tough. But when you are willing to just write every single thing out into this long expression, it's really, it's not hard at all. It's just mechanical. You just just do it. Just go through the process and do it. We're cool? All right. I have 10 minutes, and I need to get through talking about the SATs because I've been using up a lot of my time, but I haven't really gotten to talking to you guys about some good stuff. All right, so check this out. SAT, ACT. What I'm going to do is I'm going to teach you guys Chapter 13, and it's a really good chapter. I made it available for you guys to be able to download, so go and check it out when you guys can. Download the content and read it. I think it's called Chapter 13 of this thing because this Chapter 13, what I like about it is it gives you kind of these basic strategies. So this will help you on the SATs and the PSATs and the ACT and whatever test. As long as it's a multiple choice test, you're pretty golden on that. Oh yeah, that's right. Is this the new version? I'll tell you what. I don't want to cover the new version until I get through this chapter, but I will take a look at downstairs at the the new version. Got it? All right. Let's see. Okay, so let me tell you a little bit of information about both tests. Now, the SAT is a test. Here's something about the SATs. The SATs, the questions get harder. They start off from easier, and then they kind of work their way up to getting harder. So you can kind of, if you guys are asked to like estimate how hard a question is, just know that if it's generally in the beginning, it's easier, and if it's generally at the end, it's harder. That's not to say that they take maybe one from the end and put it up front, and then one from the beginning and put it in the back. But in general, they kind of keep it in order. I think for ACT, they pretty much just mix the whole dang thing up. They don't care. They're just like, I'm going to make it easy, hard, whatever. So you don't have that as a guide. So that's something that you guys should find important. What about for the is the ACT Test Explorer look like the ACT test? Yeah, it's put out by the same company, and I think that it's basically just the ACT for 8th graders or 9th graders or whatever grade it is you guys are at. Similar stuff. By the way, Sophia, what grade are you in? You 10th grade? Okay, cool. All right. For the SAT, you got to understand the idea of how they grade things. The SAT will give you 1 point for every question you get correct. But it will only give you, but the thing about SAT is they will take off, I should write SAT, ACT. All right, so I'm talking about SAT now. They will take off a 1/4 of a point for every question you get wrong. Sophia, you're saying that's not on the new test? Oh, okay. All right, that changes our strategy. Because the way the ACT works, and apparently the way the new SAT works, I'll confirm that for you guys, but the way the ACT works is they'll give you 1 point for every question you get correct, and they won't take off anything that you get wrong. So here's what I would recommend doing. I guess for both tests, since they're graded in the same way, if you don't know how to do it, guess it. But I usually make a little note on my scratch paper as to which questions I guessed. Does that make sense? so I can know to come back to those. But guess it. And you're allowed to guess because you if you leave it blank, you guarantee get it wrong. But if you guess it, hopefully you can make an educated guess. But if you can't, then do what you can. Because if you get it right, hey, that's one whole point in your thing. Try not to guess too much. Do your best to solve the problem. Some people, what I like to do is I don't necessarily guess and put a full bubble in my sheet. I don't know if you're taking it on the computer nowadays or taking it on paper, but what I like to do is I like to put a little dot right there as to what I'm guessing, but not do a full bubble in there. The reason being is because then I can come back and know I need to take a look at that in greater detail. Does that make sense? All right. Let's use some multiple choice questions to our advantage. Actually, let's see. Let me tell you a few techniques that I think would be really good. Where's my washcloth? Oh, here it is. Got it. All right. A is an odd integer. A is odd. B is even. Which one is odd? Is it 2A plus B? Is it A plus 2B? Is it AB? Is it A squared B? And is it AB squared? All right. Say, okay, A is odd, B is even. Which one of these is Gerrans-Bobarans odd? Okay? Here's what I would do. There's an abstract way of going about this. There's a totally abstract way of going about this. And you can kind of think of any two number, you can think of like, all right, let's test this one. An even number times an odd number. Well, an even number times an odd number is 3 even numbers added together. That gives me an even number. Does that, right? Like Emma's suggesting that we do C. Or it's not even, it's an odd number of even numbers added together. That gives me an even number. Look, that's all fine and dandy, and you can test out every single one you want. But I'll tell you what, here's the easy way to do it. You guys ready? Let A equal 1 and B equal 2. Because if it works for this, then it should work for all of them. And I know I showed you guys this technique like last week. If it works for this one condition, then it works for all of them. So then all you do is you plug in a 1 for A and a 2 for B. So 2 times 1 is 2 plus 2. That's 4. That's even. Not that one. 1 plus 2 times 2. That would be 1 plus 4. 5. That's odd. Good. That's it. I'm done. Now, just to try it out, let's do another one. Like 1 times 2 is 2. That's even. Nope. 1 squared is 1 times 2 is 2. No, that's wrong too. And then 1 times 2 squared, that would be 1 times 4. That's even as well. All right, Sophia, here's what I would say. How do I know for sure that that works for every single case? Well, okay, fine. Let's do this. Say that I didn't choose 1 and 2. The most easiest even and odd numbers I can think of. You, Sophia, choose an even number. Or choose an odd number. Tell me any number that's odd. All right, fine. You're going to go 3 and 4. Watch. 2 times 3 is 6. Plus 4 is 10. That's even. 3 plus 8. 2 times 4 is 8. 3. That's 11. That's odd. This works. And it will work for any even and odd number. Do you see what I mean? Yeah, 3 times 4 is 12. That's even and all that kind of stuff. And I guess here's the way I would do it, because I see what Sophia's doing. Sophia, like, I think that some of you guys would just choose a bunch of numbers and then, or choose like 2 numbers and say, okay, it works and we'll move on. But Sophia, what you're saying is, how do I know for sure? Like, it's freaking me out that you're doing it this way. And my answer is this, because I actually have to go. I got to teach physics now. My answer is this. Sophia, after you get the right answer, after you circle this one, then you can think about it. And you can say, I know that 2 times an even number is Gerens-Boberens going to be an even number. In fact, 2 times any number is an even number, right? And an odd number plus an even number will give me an odd number. So you can do it my quick way, boom, boom, and then you can sit back and think about it to make sure, hey, okay, that works. That makes sense to me. But what I'm trying to show you here is not how to solve every single problem. What I'm trying to show you is how to cheat. Yeah, Sophia, I like to know how it works too. But I'm going to do it this way first, and then I'm going to let the math tell me what to do. Does that make sense? All right, cool. I got to go. I'm sorry. I went over time with this, and I got to go to my next class, and hopefully next time we can just hit chapter 13. I can go through all of these cheating techniques. Okay, bye.